Hello there. This is an example that I was asked to explain, and I went ahead and started working it out. So I'm just going to talk about each step as we go through these slides. So first of all, this says find the distance between the given points, and we are asked to give the exact distance and also the approximate distance rounded to at least 2 decimal places. So I began by recalling the formula for distance between 2 points, and I wrote it as you would traditionally see it in most algebra books or math books. And I wrote it the way, like I said, that you would see it, but I don't think in this way. Um, I usually think x1 minus x2 quantity squared and y1 minus y2 quantity squared because I like to work from left to right. And it doesn't make a difference because honestly, you can label these points however you want. As long as you're subtracting the x values and subtracting the y values, right? So we're subtracting the x values here, subtracting the y values here. As long as you are careful to write things down with their signs and simplify everything correctly, no matter which point you consider to be the first point or the second point, it doesn't make a difference. So I think most students memorize the formula like this, then they'll go in and they'll label from left to right the first set of coordinates as x1 and y1, and the second from left to right x2 and y2. But I just wrote mine the other way around because visually I like to go with that first point. I like to go, oh, here's one x value, -1/3. Okay, that's an x value, -1/3. And then I'm going to subtract the other x value, which is here. So in the order that I see them, it just makes more sense to me naturally to write it this way. So as you can see down here, as when I started writing down my x values in the quantity squared, I wrote down the -1/3 first, then minus the second x value listed is 3. And I wrote it as 3/1 because when you're adding and subtracting fractions, you're going to need a common denominator. So the first thing I'm doing is just writing that integer or non-fraction number as if it were a fraction by putting it over 1. Okay, and then I'm going to later get the common denominator. But we're going to go ahead and write in the y values. So again, from left to right, I'm doing 3 minus 1/3. Okay, so that looks like this. Then now I'm going to start simplifying in the next step. But what if I had, like many of you might have done, the opposite? You might have, labeled this point x1 and y1 and this point x2 and y2, and then what would that look like? So if you did it the other way around, then you would have the 3 first as your first x value minus, right? And then -1/3. So what I have here is a double negative, okay, 3/1 minus minus 1/3 quantity squared plus, and then the y values, the 1/3 first minus 3 written as 3/1. Okay, so I'm just going to do both versions of this side by side to kind of, either way that you did it, you'll see that it works out to be the same thing eventually. All right, so let's go on to the next step. So here in this step, I am getting those common denominators. So the 3/1, if I multiply that denominator of 1 times 3 to get it to be common with the other x value, I just need to multiply the bottom and the top by 3 because 3/3 is 1. And if I multiply 3 times 1, it's still 3. So even though this is going to look different, it's still going to be equivalent in quantity. So that becomes 3 times 3 is 9 over 1 times 3 is 3. And notice that if I did 9 divided by 3, what would I get? I'd get back to 3, right? So that is an equivalent fraction I just wrote there so that we have that common denominator. I'm doing the same thing with the y values. multiplying the 3 that's over 1 times 3 over 3 to get 9 over 3, and then minus the 1/3. Okay, next. Do that to the other version of this distance formula. Similarly, right, just keeping track of the signs. Notice that I turned my double negative that's in that first quantity squared into a positive. So a negative times a negative, or a double negative, becomes a positive. And then the y values, we did not have a double negative. It just is a regular minus there between those. All right, now we'll go on. So in the next step, we have simplified. So now I'm just combining the fractions in each quantity. So I have negative 1/3 minus 9 over 3, or 9/3. So that gives me negative 1/3 plus a negative 9/3 is how you could think of that. We are keeping the sign the same, and you're adding the numerators. So we have a negative 10 over 3. So negative 1/3 minus 9/3 gives us negative 10/3. And that quantity, though, is going to be squared. So I made sure to use the parentheses there to contain that negative, because the negative is part of the number that's being squared. Then my y values, 9 over 3, so 9/3 minus 1/3. So 9/3 minus 1/3, 9 minus 1, 8/3, quantity squared. What about the other version here? So I had 9/3 plus 1/3 gave me 10/3, and 1/3 minus 9/3 give me negative 8/3. So notice that I have a positive 1/3 and a negative 9/3, so they're opposite in sign. We keep the sign of the larger number and subtract the values, so we have negative 8/3, okay? Now, if you look at these two versions, on the left we have quantity, negative 10 quantity squared. And on the right, in the other version, we have positive 10 quantities, positive 10/3 quantity squared. So the only difference between this on the left and that on the right is that the one on the left is negative inside the quantity, and the one on the right is positive inside the quantity. And likewise for the y values. On the left-hand version of this, I have a positive 8/3 in the quantity, and on the right, I have negative 8/3 inside the quantity. So when we go to the next step of simplifying the squares to the power of 2 on each of these, what's going to happen? Well, I rewrote it in expanded form just so that we could visually see what's happening here. The negative 10/3 squared, okay, the negative 10/3 quantity squared, I rewrote that as negative 10/3 times negative 10/3, because I wanted to make sure you could understand that it's a negative times a negative, and hopefully you recall that anytime you multiply two negatives, you get a positive product or a positive result, right? So then positive 8/3 times positive 8/3, of course, is going to stay positive because they're both positive. Over in the right-hand version of the distance formula, I have positive 10/3 times positive 10/3 plus negative 8/3 times negative 8/3. So again, that negative 8, the two negatives are going to become a positive product when we simplify. Right, so now you can see in the next step, that gave me 100 over 9 underneath the radical, 100 over 9 plus 64 over 9. So the negative 10/3 times the negative 10/3 became positive 100/9. Why? Because we're multiplying the numerators to numerators and the denominators to denominators, and we have a negative times a negative, so we got that positive result. And then 8 times 8 is 64, 3 times 3 is 9, so we have positive 64 over 9. Then on the right-hand side here, in the other version of the distance formula, we got the same exact thing happening, right? Because the two positive 10/3 that multiplied together gave us 100/9. And the negative 8/3 times negative 8/3 became positive 64/9. So what we have here is a result in this step that is identical. These two versions are now, looking the same in every way. So from here on out, I'm just going to write one side of this. So in the next step, I'm just combining, now that I have 100/9 plus 64/9, I'm going to combine that, keep the denominator 9, and add the numerators. 100 plus 64 is 164/9. Then to simplify this, I'm like, oh, well, 9 is a perfect square, so we can rewrite this as separate radicals being divided. So another property of radicals you would have learned about in a previous class, that you can split them up like this. So I rewrote it as square root of 164 divided by the square root of 9. So then that simplifies. In the bottom, the square root of 9 just simplifies to 3. And then in the top, I said, 164, that's not a perfect square, but I'm pretty sure a perfect square might divide into that or be a factor of that. So I went over to my calculator and I started dividing 164 by perfect squares that I'm familiar with. And it turns out that 164 divided by 4 gave me 41. And 41 is prime, so that's what we need. So I rewrote in this step the square root of 164, rewrote it as the square root of 4 times 41 in the numerator here. Now the square root of 4 can simplify out to 2, and then the 41 stays under the radical. So now we have 2 square roots of 41 over 3. Or you could write it as 2/3 times the square root of 41. Either way would be considered correct. And now that answer would go into the exact distance answer box. And we still have to come up with an approximated answer to at least 2 decimal places. Okay, so to do this in a scientific calculator, depending on the model of the calculator, you might do it in different ways, but I'm going to show it just with the one that's on my computer. It's not my favorite way. The way this calculator works is not my favorite way to deal with a calculator. I like calculators that allow me to write things out as I would write them on paper. And I did recommend my favorite calculator and a couple other good ones in the syllabus. However, I don't have anything I can show you on screen to mimic my favorite calculator. So we're just going to go with this. So I'm going to show you how I did this. You can kind of see what I did over here, but I'm going to take us through the steps again. So first thing I'm going to do, because of the way this calculator works, I have to put in the 41 first and then square root it. Okay, so the square root of 41 is 6.4 something. And that seems right to me. You always want to think about if this seems right to you. How would you know if that seems right or not? Well, you need to practice, getting good at number sense. So I'm just going to put on the side over here. If you want to know what the square root of 41 should be approximately equal to, you can think about what other two perfect square roots or two perfect squares are before and after it. So if I'm remembering my perfect squares that I am familiar with, like 1 squared, 2 squared, 3 squared, and so on, I get down to, I think I want to look at 6 squared, which is 36, and 7 squared, which is 49, right? So the square root of 36 is less than the square root of 41, and the square root of 49 would be greater than the square root of 41. So I know that since the square root of 36 simplifies to just 6, and the square root of 49 simplifies to just 7. Now I know that I'm expecting the square root of 41 to be somewhere in between 6 and 7. So when I went into my calculator, I and saw that I got 6.4 when I square rooted 41. I look back at this and I think, okay, that makes sense. 6.4-ish, right? 6.4 something. It's not exactly, but some about 6.4 makes sense for that number. Now, why is it so important to do that? Because calculators, each calculator has its own, they can operate differently, and you should just keep track of each step that you're doing and make sure that you're somewhere in the ballpark. So it is really important to have number sense, even if you do have a calculator to lean on. Okay, now I've got that part of it, right? So I did that first just because of the way that this calculator operates. I had to put in the 41, square root it, and now take that quantity and start multiplying it times the 2/3. I'm going to actually think of it like the step before it. 2 times the square root of 41, then that product divided by 3 is just a little easier. So I'm going to start with, I've already got my square root of 41 in the calculator. Now I'm going to multiply it times 2 and then divide that by 3, right? But I'm just going to push the equals first because I want to make sure. I know that the square root of 41 was about 6.4-ish. So if I were to multiply that times 2, I'm expecting to get around 12.8-ish, right? So notice that that's what I got, right? 12.8-ish. And now I'm going to divide that by 3. Now I know that 12 divided by 3 would be 4. So 12.8 divided by 3 is going to be a little more than 4, or 4-ish. Okay, so I'm going to divide by 3 now, then press equals. So there you go, 4.2687. That looks about right? And we were supposed to give our answer, our approximated answer, approximate to at least 2 decimal places. So I'm going to I could put in this whole number probably, or all right, so I'm going to put my approximate distance right in here and just see what happens if I submit it like that. Oh yeah, it was fine. But it said to round it to at least 2 decimal places, and most of the time, if you're working with a handheld calculator, you're not going to want to put in that many numbers. So you just have to make sure to round it to where it's telling you to, so that it can be marked correctly. And I do expect you guys to pay attention to those rounding recommendations or instructions and follow them correctly. So sometimes I get students even sending me a message from a test question. Oh, I had it right, but I just didn't round it exactly right, or I didn't round it to enough decimal places. And that is still an incorrect answer, although I do tend to give some credit back sometimes, depending on the situation. But just know that you want to get to where you're really good at making sure you've read carefully before you submit your answer, because that's a really important skill. Above and beyond math, it's just important to, make sure you are paying attention to detail. All right, so I'm going to round this second digit after the decimal, right? So that 6 with the 8 to its right means I'm going to round the 6 up to 7. I could have done more decimal places, but I'm just going to do 2 because it said 2 or more, at least 2. That works. Okay. Now the exact distance, you would just put it in as either 2 times the square root all over 3 or 2/3 times the square root of 41. Either one. Okay. So I'm going to go ahead and put that in. So usually I like to have my fractions out separately and then the square root of, what was it, 41. Okay, so that should work fine. Or if I had written it as 2 times the square root of 41 and then divided that. Ooh, that's not what I wanted. This is what I wanted. There we go. Divided by 3. That also works. Okay. And still another way you could have written it is 2 times, I don't know if it's going to let me do it this way, but you could have done square root 41 divided by 3. So you could have put the 40 square root 41 over 3 and the 2 out by itself. Like these are all correct versions of the same thing, just so you know. Okay, well, I hope that was helpful. And actually, I think I'll do maybe one more of these, just give us a little more practice and show it a little faster. So take that. Oops, I did not do a good job. Let me try again. All right, we're going to go ahead with this. All right, so now I do not really think about the distance formula too hard. I just think subtract the x's and square the result, subtract the y's and square the result, add those together, and then take the square root. So even though, you know, it's great to memorize things, or you can even put them on your formula card, I don't do that. I've explained that in some other videos. I always just think the distance between the x's squared plus the distance between the y's squared, and then take the square root of all that. So and remember, I told you I think from left to right. So I'm not even going to label my x's. This is what I mean. Like I just go, oh, here's one x, here's an x, 7 halves. And I'm going to subtract the other x. Here's another x. Does negative 7 halves. So that double negative is going to become a positive. Okay, so now I got that first part done. Just subtracting the x values. Now I'm going to subtract the y values. The first y value I see is 5 halves. All right, 5 halves. I'm going to subtract the other y value, which is 1. And since it's 1, I could write it as 1 over 1, but I know I'm going to need that common denominator, so I'm going to go ahead and write that as 2 over 2, because any number over itself is 1, and that'll just save me some time. Okay, and then I'm going to now simplify the fractions. Now these values, because this is the same problem just regenerated with new values, and this one turned out to be a little easier because my fractions already have common denominators, so that's nice. So 7 plus 7 is 14, 2 times 7 over the the common denominator of 2, okay, quantity squared. Then 5 minus 2 is 3 over the common denominator of 2, so 3 halves, quantity squared. Then I'm going to square 14, so 14 times 14. I don't actually have that memorized. I think my perfect square memorization stops at 13. So we're going to do that in here, 14 times 14, or I could have done 14 squared, but here we go, 196. Okay, so 1, woohoo, hello, sorry, give me a moment to fix that. It's just bugging me. I think I could have gotten by without messing with it, but uh-oh. Okay, 14 squared, 196 over 2 squared, which is 4, and 3 squared is 9 over 2 squared is 4. Again, we have common denominators. That's awesome. So I'm going to keep the common denominator of 4 and just add the 196 plus 9. Now 196 plus 10 would be 206, but it's 1 less than 10, so that'll be 205. And then we can take the square root of 4 and simplify that. 205 is not a perfect square, so I'm going to leave that in the radical up top. All right, now I do, though, suspect that there might be a perfect square hiding inside of 205, and any number that ends in 5 is divisible by 5. So let's just start by taking 205, and we will divide it by 5 to see what our other factor is. Some of you already know. Right, so I got 41. Aha, okay, that's interesting. Kind of coincidentally, the same prime number that we had remaining under the radical in the previous example. Okay, so I'm going to rewrite this. Oh, but yeah, that's not going to help us. Right, so 5 times 41 over 4. Yeah, so 5 is not a perfect square. 41 is not a perfect square. They're both prime. 5 is prime, meaning it can only be broken down to 5 times 1, and 41 same. So actually, this is our best, most simple version of the exact answer. So we'll go ahead and put it in square root 205 over 4. Uh-oh, I messed up somewhere. Oh, of course, because the square root of 4 is supposed to be 2 when it comes out of the radical. Silly. Okay, so that should have been a 2. I apologize. So let me get my 2 is there. And that should fix the situation. Okay, now to get the exact answer, just clear everything out. I don't know if it'll let me, I wish I could get rid of everything. Memory clear maybe? It won't let me clear out everything. Okay, well anyways, I guess this is as clean as we can get it right now without spending too much time trying to figure it out. So I'm going to put 205 in, then square root that, and then I'm going to divide that by 2. So that would be 7.16. Okay, all right, great. So I hope that helped you, and I'll see you in the next video.